Good morning, class. Today's lesson is on arithmetic sequence, specifically how to write recursive and explicit rules. So, we've learned previously that these two sequences are arithmetic sequences. Okay, by sequences, we just mean a specific order of numbers in this case. Now, if you pay close attention to these sequences, you should notice that for the first one, we keep on adding 3. Okay, so each time, in order for us to get this next numbers, we add 3. For the second one, in order for us to get the next number, we take away 5. So, the reason why we have to do that is because this one now, the plus 3 and minus 5, these are what we call the common difference. Okay, we denote this using the letter D. And we will use these later. So for the first one, our common difference, our D is equal to positive 3. For the second one, our common difference, or our D is equal to negative 5. We will use this information now to write the rules. So here are the formulas that we need to be aware of for this section. Okay, so the first one, for the recursive rule, we have to know A sub n. We read this as A sub n. Think of a submarine. Equals A sub n minus 1 plus D. Okay, A sub n and A sub n minus 1. What do those two terms mean? Is that, for example, if this was A sub n just means the current term. Let me redo that. Suppose this is A sub n, the current term. A sub n minus 1 is the term or the number before it. So if that was A sub n, this would be A sub n minus 1. Okay. Similarly, if Similarly, if 8 was A sub n, if this one was A sub n instead, okay, if this was the current term or the current number we're working with, 5 would be the number before it, so 5 would be A sub n minus 1. That's just what we mean by A sub n and A sub n minus 1. They are two numbers that are after, in which one is after the other. So two consecutive numbers, A sub n and A sub n minus 1. Now for recursive rule, all we have to do is replace the D in our formula. And we learned earlier here that for the sequence 2, 5, 8, 11, our D is equal to positive 3. Therefore, our final answer for the recursive rule here is A sub n equals A sub n minus 1. And like I said, I only replaced D, so plus 3. And that's it. That is the answer if we are looking for a recursive rule. For the explicit rule, almost the same thing. There's just a new symbol, the A sub 1. The A sub 1 means the first term or the first number. So in our sequence here, 2 is the very first number. So that is what we call the A sub 1. In this case, all we have to do for explicit rule, replace A sub 1 and replace D. So this becomes A sub n equals 2 plus our D, again, same thing as earlier, our common difference, 3 times n minus 1. And that's it. That's all I'm asking you to be able to do. Okay, so let's do the same thing now to the other sequence. So as we said, for the recursive rule, A sub n and A sub n minus 1 just means they are two consecutive terms. D is the common difference. So we mentioned in the second slide that the common difference of this is negative 5 because each time we take away 5. Therefore, the recursive rule now just becomes A sub n equals A sub n minus 1. Now plus D, so we can do plus negative 5. But note that plus negative just means minus. So our final answer for recursive rule here is A sub n equals A sub n minus 1 minus 5. For explicit rule, same thing. We just have to do our A sub 1. A sub 1 means our first term, our very first number. So this becomes A sub n equals 8 plus our D, which is again negative 5, parentheses, and minus 1. Note again, are plus negative. So this one, the final answer will be a sub n equals 8 minus 5 parentheses and minus 1. Now for those who really get this, there's actually a further way to simplify the explicit rule, and I will just show it for enrichment. Okay. So for example, for our answer in the first sequence, we said for the explicit rule, it's a sub n equals 2 plus 3 parentheses and minus 1. You can simplify this further if you want to. This is optional, guys. By distributing the 3. So distribute means we multiply the 3 to the inside. So this one now becomes plus 3n. 3 times 1 or 3 times negative 1 minus 3. And we copy the 2 in front. So a sub n equals 2 plus 3 and minus 3. Combine like terms, 2 and negative 3. If we combine that, our final answer will be a sub n equals negative 1 plus 3n. Okay, and similarly, lastly, we can do the same thing again. This is optional. If we want to simplify further, we can distribute negative 5 for the second. This is for the second explicit rule. And we get negative 5n. Now this we have to be careful. Negative 5 and then negative 1 will make positive 5. So our a sub n equals 8 minus 5 and plus 5. Combine like terms again. 8 plus 5 equals 13. So there is our final answer. And we're all done. Now, let's go back to the this one. For example, why do we have an explicit rule and a recursive rule? The idea with the recursive rule is if you know the number before it, then you can find the next term by, in this case, adding 3. So, for example, after 11, we can easily find the number after it by adding 3. So the fifth term will be 14. The problem with this is, what if I'm asking you for the 293rd number in this sequence? Okay. The idea then with recursive rule, if you're still going to do it, is you have to keep on adding 3 until you get to the 293rd number. So I don't think you want to do that. That's the idea why we have to use the explicit rule. So for the explicit rule, all we have to do then is replace n by 293. So we're actually looking for an a sub 293. That just means the 293rd term or the 293rd number, and replace n by 293 and solve. Use your calculator, guys, and you should get the 293rd number in a much shorter way than if you added 3 each time. That concludes our lesson. Good luck, guys.